Object-oriented programming in Python. Inheritance. In our Object-Oriented Programming series Lesson 1, we have learned the basics of object-oriented programming, and in Lesson 2, we have learned the structure of a class in Python. If you are new to OOPs, then please watch those lessons first, otherwise you may proceed. Here we will discuss about inheritance in Python. So, what is inheritance and how to use this feature in Python? Inheritance is the technique of acquiring the features of an existing class or parent class by a new class or a child class. It helps in the reuse of existing classes and incorporating new attributes and methods to the child class, keeping the parent class or the base class unaltered. For example, consider a class, person. A person may have many attributes, but for simplicity, consider it has only 3 attributes: name, sex, and date of birth. When we create objects of the class, person, all the objects will have these attributes. Now think about another class, employee. Aren't employees persons too? Surely, all employees are persons. So, all employees should possess the attributes of the persons. But employees have few additional attributes such as employee ID, department, etc. In this example, EMP_ID and department are additional attributes that person class don't have. So, we may create a derived class, employee, from the base class, person. The employee class will inherit all the attributes and methods of the person class, and it will have some additional attributes and methods. Obviously, when a person becomes an employee, he or she will have profession or organization-specific attributes and behaviors. So, we have covered the basics of inheritance. Let's implement the person and employee classes in Python. First, define the person class. We will not discuss how to define a class here as it is already covered in Lesson 1 and Lesson 2 on OOPs. Just follow me on while I type. Constructor method for initializing the instance variables. Instance variables or attributes of the person class are name, sex, and date of birth, DOB. The person class has also a method for displaying its own attributes. So, this is the complete definition of the person class. Let's create few objects of this class. Let's test the code in the terminal. And, yes, it's working. So, our person class is now ready. Our person class has 3 attributes, name, sex, and DOB, and 1 method, display. Now we will create a new class, employee. And employee class will inherit the attributes and methods of the person class. Defining the constructor method for the employee class. We need to supply the attributes for the person class as well as its own attributes. Here, name, sex and DOB are attributes of the person class and EMP_ID and department are additional attributes for the employee class. As the base class, person, has its own constructor, we need to supply the constructor arguments from the derived class, employee. We can do this using the super function. Super function gives us access to methods in a superclass from the subclass that inherits from it. In the above line of code, we are passing the name, sex, and DOB attributes to the constructor of the person class. Now initialize attributes unique to its own objects. In this way we are initializing the instance variables of both the base class and the derived class. Now let's define another method, display here, for displaying the attributes of the derived class objects. Carefully observe that we are defining a method named display here. The parent or base class has also a method named display. We don't want to use the display method of the base class here. So, we are redefining it here. This is also known as method overriding. Now defining the base class and the derived class is complete. Now let's create few objects of the derived class, employee. Let's test the code in the terminal. So, our derived class is working fine. That is, we are able to inherit the attributes and methods of the parent class into the child class. What you have learned so far in this lesson is just an introduction. This is necessary for understanding the concept of inheritance. You may wonder, when we have to write both the base class and the derived class, then what is the use of this? We may define our required class completely without using any other class. If you think so, then you are right. But think about a real-life project where so many developers are writing large code bases in different modules from different parts of the world, then inheritance is very useful for reusing the same code base with some additional features. For example, suppose our person class is defined somewhere in the xyz.py module. We can import this module in our new project and use the classes defined in xyz.py as it is, or we may create new classes with additional features through inheritance. As you can see, the XYZ module has many classes and our interest is the person class. As the class is defined here, we can reuse this class in other modules. Let's create a new class, employee, by inheriting the attributes and methods of the person class of the XYZ module. First, import the person class from XYZ module using the import statement. Now we will create a class, employee, by inheriting the attributes and methods of the person class. Here I am just copying the code written earlier for saving time. The beauty of inheritance is that we need not rewrite the codes again and again. Here, we have created the employee class very easily, in less time, and on top of a well-tested code by other developers. Let's test our newly developed class, employee. This is all for today's lesson. Here we have learned the basics of inheritance in Python. There are various types of inheritance. We will learn more about those types in our next lesson. Thank you very much for watching this lesson up to the end. Please like, share, comment and subscribe the channel for more such important lessons. Happy coding, bye!